Hey everyone, welcome back to the channel and to another video in our Databricks series. Ever wondered how Databricks actually handles our Delta Lake files behind the scenes? In our previous video, we saw the core concept of Delta Lake. We understood the theory behind Delta Lake, we understood the lakehouse architecture, and also had hands-on session on the core features of Delta Lake. If you have not watched that videos, I would highly recommend watching those videos first. You can go to my channel AI2 Deutsch, and here we have the theory video, and in this is the practical video where we discuss the core features of Delta Lake. Today in this video we are going to see how files are actually managed in Databricks, and we will see how to work with files in Databricks. So let's get started. So today we are going to discuss about DBFS and dbutils, which is basically the file system of Databricks. So let's start by understanding what is DBFS. So DBFS is basically a distributed file system which acts as an abstraction layer over your cloud storage. So your cloud storage could be S3, your Azure storage, or GCP storage. So DBFS provides us a unified and simple interface to store, access, and manage our files, right? So the goal of DBFS is very simple. It wants to make it easy to store, access, and manage our files in Databricks without worrying about cloud complexities. Okay, suppose we are working on Spark and we have multiple clusters, maybe one for testing, one for production, and one for ML experiment. So Databricks is telling us you upload your file once in DBFS and all your clusters can basically directly read from that path. For example, you have a data.csv file and you upload your file into this path, right? And all your cluster can directly come and read this data.csv from this path. Okay, it doesn't matter how many clusters you have or which cluster you are working with, all the clusters can basically come here and read it from this path. Okay, so it's like a shared Google Drive folder that everyone in your team can access, right? And DBFS path starts with DBFS, this one, and it is basically like you can organize files and folders just like a regular file system. Okay, but why Databricks is even telling us to upload our file once in DBFS? There must be some problem, right? So what was happening before? Like suppose you are working on Spark and you have different clusters, right? You have started maybe, for example, 3 clusters. Okay, and your cluster need to pull data from your S3, right? But accessing cloud storage directly used to be a total pain. Why? Because every cluster needed access keys to talk to your cloud storage. Okay, so they used to hard code their keys in the code. So if you are hard coding any secret keys in your code, that immediately makes it insecure, right? So that was one problem. So if you have 10 clusters, all of them have to basically hard code their keys in order to get the access. Okay, and then they could able to read this file from your S3 bucket. So this was one problem, and if for example anything goes wrong, then your job would crash. Okay, another problem was direct cloud access was laggy because of network delays, right? Suppose you want to work on a big data sets, right? And because of the network delay, it would take forever to load that data. So slow connection was again a problem. And because this direct access was so tricky and slow, and because of the and had credential issues, what clusters used to do? So different teams used to copy data from S3 into their cluster's local disk to make things faster and easier. Okay, so for example, they had to pull a 10 GB CSV file from S3 to cluster temporary storage, and if there are 3 clusters, then there would be 30 GB of duplicated data. So this was again a problem, right? So because of these problems, Databricks came and said you upload once in DBFS and all your clusters can access this file from DBFS. So no need to copy this data, and DBFS would basically handle the connection to the cloud. So all your clusters need to just come and read from this path and don't have to manually write this credential into their code or think about anything, right? So this makes things easier for them. Okay, but then another question arises, like what if your data was already in S3 bucket, right? because here let's suppose you are working with some more big files. So Databricks said, okay, we will let you mount that S3 bucket in DBFS. Okay, so it felt like a local folder. For example, you could link an S3 bucket to your DBFS mount my bucket. So basically you can able to mount your S3 bucket into DBFS. Okay, so you would do something like dbutils fs mount. So this is your source and this is the point where you will mount your S3 bucket. But here also you had to define your access key and secret key. Okay, so once mounted, any cluster could read the data like it was in DBFS. So this was another solution if your data is already in S3 bucket, right? This was again very helpful, right? Because it gives you a shared location for cloud data, just like DBFS own storage. All cluster could access the S3 bucket without copying data, solving the duplication problem, right? But now mounting is deprecated because of the security issues. You had to hard code credential in the notebook. So here we see where we had to hard code our secret and access keys, right? So anybody could basically steal your keys and access the entire S3 bucket, right? And once mounted, anybody basically could read all the files which is there in your bucket. So there was nothing like only read this folder. And if you had 10 buckets, you would need 10 mounts. So if credential changed, you had to remount everything, which makes it hard to scale, right? Mount did not work well with modern tools like Unity Catalog, which tracks and secure data access. It was hard to audit who access what, and which is a problem for your GDPR compliance, right? So that's why now the mounting is also deprecated. So now in the modern approach, what is happening, we could directly access our data directly from the cloud. So with this advancement in technology and with all the development, now we can directly access our data directly from the cloud. Okay, so which makes it super secure. Instead of hard coding keys, you could attach an IAM role to your Databricks cluster in AWS or a managed identity in Azure, right? And through this IAM role and this managed identity, each cluster can now have specific access rights for your S3 data, right? So no keys in your code, so you don't have to hard code any keys. So this is what is happening in our modern approach, right? Reading data directly from S3, so we can directly read data like this, right? So the cluster's IAM role handles the authentication, and you can set permissions to limit access to a specific folder as well, right? So now it makes it very fast, right, in the modern approach. And modern cloud connectors like these and are super optimized. They are fast even for huge data sets. Okay, Unity Catalog came, which is basically providing us the governance. You define your data as tables in Unity Catalog. We are going to understand about Unity Catalog in our future videos. Okay, so basically in Unity Catalog you defines your data as a table in your Databricks, like your you define it like this. You give my catalog, my schema, and my dot my table, and it points to your cloud storage. Okay, so users query it with SQL, and Unity Catalog checks the permissions. Okay, because of these advancements, now mounting was deprecated. Okay, so basically with Unity Catalog, you are basically creating this table using delta, and you are giving this location. And if you have seen my previous video, then you know if we give this location, that means we are creating an external table, right? And we can now, our data is actually residing in this S3 bucket, but we could access that data from this table. So we will perform all the operations through this table, right? So users don't need to know the S3 path or mess with credential. Plus Unity Catalog tracks who is accessing what. So perfect for GDPR compliance, right? And it is also scalable. So direct access means no managing mounts. Got 100 buckets? Yeah, just use S3 path. Okay, so why do we want to directly read data from S3 now? Because it is secure, it is fast, and it is also governed through Unity Catalog, and it is scalable. So it gives you all the benefits of DBFS shared access, right? Clusters read from one cloud location, no duplication, without the headache of mounting. So now you must be thinking, okay, if direct access is possible, then do we even need DBFS now? Yes, we could still use DBFS if we are working with some small files or testing. So what we can do, we can just upload our file directly in our DBFS file storage here, and if the file is small or if you want to test anything, we can still do this, right? We can upload directly to our DBFS, right? But don't get confused with mounting is deprecated. Here we have, if we have just small files for testing or anything, we could simply download it in our or store it into our DBFS path and can access it, right? And if we are working with notebook or libraries, we could save the notebook outputs, ML scripts into our DBFS so that other clusters can access it, right? So if we want to share a small data set across cluster, we can still use DBFS, right? But for big data set, production pipelines, or data that needs tight security and governance, skip DBFS and go straight to the cloud using this or Unity Catalog, right? So that was basically your DBFS. So the key takeaway is DBFS is like a shared Google Drive for Databricks, letting all clusters access files from one central location using path like this, right? It solves big problems like data duplication and slow cloud access by giving us a unified file system. In past, we mounted S3 bucket in DBFS, but now it is deprecated. And today we can use direct cloud paths like this with IAM role and Unity Catalog for secure, fast and governed access to big data. DBFS is still good for small files, notebooks and sharing across clusters, but for production it is recommended that we directly access file directly from our S3 storage. Okay, so that was about your DBFS. So now the question comes, like, how do we interact with this DBFS, right? So to interact with DBFS, we have dbutils. So dbutils is basically a command line style utility inside Databricks. Okay, so if you want to interact with your DBFS, we have to do it through dbutils. Okay, so let's see what are the different utilities which is there in our dbutils. Okay, so if we simply run dbutils.help, we will see these options. Okay, so we have this credential utilities for interacting with credential within notebook. We have data utility for understanding and interacting with data sets. We have this fs, which is basically your dbfs file system. So we are going to see how to use this fs to interact with files in dbfs. Then we have job, library, meta, notebook. So we have different kind of utilities. Okay, so let's first start with fs, right? Because this is our manipulating the Databricks file system from the console. Fs is basically your file system. Okay, so what are the different utilities which we have inside fs? So we can see that using dbfs.fs.help command. Okay, so this will provide us the utilities working with file system. And in notebooks, you can also use %fs to access our dbfs. Okay, if we see fs utils, there we have this copy command. We can use this head, list, make directory, move, put and remove. And we have this mount, but mount is now deprecated as we discussed, so we will not talk about this mount. Okay, so now let's see how these functions work. Okay, so what we can do, and before that, if we want to run it, so let me attach a cluster. So you go to my cluster, you attach a cluster, because we know from our previous video, if we want to run any cell in our notebook, we have to attach a cluster, right? Okay, so let's see these commands one by one. Okay, so we are seeing this list command. So we are saying fs is our file system which we can access through dbutils. So dbutils.fs.list, and we want to list everything which is there in our current directory. So, and if when we display it, basically then we will see, okay, in our current directory we have these files or folders available. Okay, and we also saw we can use %fs, right, shorthand, to access our dbfs. So how we can use it, we can do %fs. So we want to list everything which is present, for example, in our file store, and we see that, okay, we have this tables folder available in our file system. Okay, so that is your list command. And if you want to go inside, list everything which is inside this table, then we see that we have a my csv file and we have this my delta table folder available. So that is basically your list command. Okay, so now let's suppose we want to copy our file from one place to another. So what we will do, we will simply do .cp command, right? So what we are saying, copy my file.csv, which is here, right, in this path, into my data.csv inside my file store. So if we again list now in our file store, we will see that okay, now we also have data.csv. Earlier in my file store we had only tables, but now we also have data.csv because of this copy command. So this is how you will do the copy command. Here we can even read the csv file which we have just copied, and we could also use our head command to see few datas in our this file using your head command. Okay, and the another function was dot put. So with this put, it is basically telling to put something in your into this file. So if we come here, so put is telling us to write the given string out to a file encoded in UTF-8, right? So with this we can say okay, so we are putting this string into our hello.txt, right? And if we do the head again for the hello.txt, we can see this string. Okay, and this mkdir is like making directories. So we are creating this model directory, and we had another command for removing, so we could remove this data.csv. Okay, if we run this command, for example, in order to remove .fs remove and this table, right, so it says directory is not empty, therefore cannot delete. So basically if you try to delete a directory using rm, if it is not empty, it won't let you delete it. And if you still want to delete it, you can use this -r recursive option to delete everything from this table. So recursively it will drop all the files inside this table, and then it will drop this table as well. Okay, I just wanted to show you this recursive command as well. Okay, so now if this again I am doing this ls to see okay, these are the tables inside this. Okay, so that was from your, this is how you can use different utilities available in your fs, right? So fs utility, we saw copy, simply we are copying the content. We see head, list, make directory, move, put, and remove. So yeah, so very simple, right? And if we see another utility, so this was your fs utility. Now another important utility is your widget utility, right? So it is basically a methods to create and get bound value of input widget inside notebook. Confusing, right? So let's see what widget gives us. So dbutils widgets.help. To if we do this, then we could see okay, what are the different utilities we have under widgets. Okay, so dbutils widget provide utilities for working with notebook widgets. You can create different type of widget and get their bound values. For more info about the method, use dbutils widget.help and the method name. Okay, so what different methods which we have this combo box. If we want to create a combo box inside input widget with a given name, default value, and choices. Okay, if we want to create a combo box, if we want to create a drop box, if we want to get value from any of these widgets, we can do that using this get command. Then we have this remove, multi-select, remove all, and text. Okay, so basically in order to create something, or in order to create a widget, we have this text. So creating a text widget, we have this we can create a multi-select option, we can create a drop down, and we can create a combo box input widget. Okay, so let's see one by one of this. Okay, and what I have written here, Databricks gives you preloaded data set at this. Okay, you can list them like this. So there is already some preloaded data sets which is being provided by Databricks to us, which we can list using our ls command, right? Because this is data set is present into our dbfs, and we know like we can use this fs now, dbutils.fs, to see what is there inside this folder. So we do %fs list and data set. So we see okay, we have these different data sets. Okay, so I have chosen just a random data set. So this airline data set where we have this different files, and let's read this 2001 csv file. So I just randomly chose one file just to demonstrate different widgets. Okay, I am selecting only year, flight number, origin, and destination from this csv file. Okay, and this is our data, right? Okay, so now as we have to work with widget, let's first create a list with the distinct value of this origin column. Okay, but why we are doing this? because we just saw like into our widget we have different widgets like text, we have drop down. So in order to use these things there has to be some value in it. So that's why what we are doing, we are basically creating a distinct list from this origin column. So we are selecting this column, we are doing this distinct, we are collecting all the data and basically writing it inside a list. So now you have a list called origins. Okay, if you are wondering why we did row.origin, because collect gives you a list of rows object like this. So we will have a row origin jfk, row origin this. Therefore in order to get this value we did row.origin. So now we have a list called origins. Okay, so now let's create our first widget drop down. Okay, right now we see there are no widgets available. Okay, so what we have to do based on our syntax, so we have to define a name. So we did name is equal to origin, we have given a default value jfk, and we have this option of choices. So here we are passing this origin to our choices, like create my drop down with these choices, and label we are just displaying the label with source. So let's run this command and let's see what happens. When we run this cell we now see a widget here. So the name was origin, here we see the origin, and label is source. Okay, and this default value is jfk, and if I open this then we see all the values from our list which we have created from our origin. So this is our drop down list, right? So if I do dot get, so this is another command inside this widget. So if I do get this origin, so this name should be, so here we have to define this name. Okay, not the label but we have to define the origin, the name which is basically we are given to our widget. So here if we run this then we get this value which is being displayed in our widget. Okay, so if I change this, make it DAB, then this is automatically changed. How this is automatically changed? Because if we see here the settings, here on widget change, right, we have this run accessed command. Okay, so we have different options, we have run notebook, we have do nothing, and run access command. And because of this run accessed command, as soon as we are changing our widget, that cell is basically also changing. If we do run notebook, then our whole notebook will start running. So let's keep it run access command. So that's why if we change this value then this will automatically change. Okay, so now let's create another widget called text, right? So again we are giving a name, default value, and a label. If we give this, run this, then we see another widget called text here with this value, default value, right? And if we do this get display text is basically the name, then we see here the jfk which is here, right? And if I change this to maybe this one, then it automatically runs and we see this value got changed. Okay, makes sense. Now let's see this multi select. So similarly we will create another widget called multi select, name was multi origin. So here, so it is like a, we can select multiple values. So right now for example if I run this one, then we see this ROC was here, and then if we see, make this one, click here, we see ROC PGM. Okay, and another widget was combo box. So again same, if we create combo box and then get this combo, so we got this value. Okay, so with combo box we have both the options. So if I change this to something, then this value will change. Okay, and we have basically the feature of text also, and we have this option of choices also. So if you cut it and then go change another value, click, and then this will automatically run, and then this value will get updated because of this get. Okay, so now the another benefit of this widget is we can basically use these widget to filter our data frame also. So here what we are doing, we are filtering our origin column based on this widget value of origin. Okay, so if my so whatever value we get from origin, our filter my data frame based on this. So if I run this one, so here now we see all the values which were in origin and which is basically your SUX, right? So all the values here is now filtered based on our widget value. And if we change this widget, then this cell will automatically run, and then we see now we have the origin this value. Okay, makes sense. And if you want to remove any widget, so let's suppose you want to remove combo, then we just use this remove, and now the combo is removed, right? So that was your widget. Okay, so now another utility, if we see above, notebook. So utilities for the control flow of a notebook. Okay, so let's see what it is. So dbutils notebook.help, right? If we do this, then we will see different functions which we have this exit. So these method let you exit a notebook with a value and run. So this method runs a notebook and returns its exit value. Okay, so let's try. So in order to run this, in order to use this widget notebook, basically what it is telling, if you want to run a different notebook from your current notebook, then you can do this using your notebook widget basically. So for that I have created this test notebook. So let's attach a cluster first here, which is already running. So I have put some commands here. So notebook help, and then here I am reading this data frame, right? So from this file location, so we have this, and here creating another text widget and then getting the value. Okay, and this exit command we are going to see in a while. Okay, so these are some things which I have written in my test notebook. Now if I want to run this test notebook from our dbutils and dbfs and dbutils notebook, what we can do, let's try to use this command first. It is just I wanted to show you. If we use this using dbutils notebooks.run, because earlier what we used to do, we used to run other utilities like this, right? dbutils widgets.function. But with notebook, this is not working like this in community edition. So dbutils.notebook.run, this will not work. So for that we just have to use this magic command %run. Okay, so %run, and then we give this path to test notebook, right? So let's run this, and now here we see, okay, all the things which was there in our test notebook is now running here. Okay, so we had all these values in our test notebook. We had this notebook module, this, and then we had this data frame, we have this widget, we have this some text here. So everything came directly here. Okay, so all the output which was there in test notebook is now visible here as well. Okay, and because we have created a data frame as well in notebook, in test notebook, so we could now use that data frame in this notebook as well, right? Because in this notebook we have created our data frame here. So df test is created in this notebook, and now because we have run our test notebook from this notebook, so we could simply use it, df utils. So I'm creating a new column, and if I'm displaying it, I could able to see this new column available here. Okay, and there was a widget also defined in this test notebook, so I can simply use that widget which was defined in test notebook like this. Okay, so now there is one more feature of parameterization. So basically what you are saying, so you are saying like run test notebook, but your test run should be okay. So you are passing this okay value as a parameter. So whenever this test notebook will run, the widget which has this text run as a name will have this value. So if I run now this, now you will see that instead of previously we had jfk, now we have this. Okay, so this is another option. If you want to run another notebook with a parameterized value to your widget, you can do it like this. Okay, so that was your notebook. And in notebook we also have exit command, right? So we see here is then exit. So what is the use of it? So let's suppose we are writing this, let's uncomment this, we are writing this exit below are the private cell. So let's suppose we don't want to run below cells from this notebook to another notebook, right? So we will do this exit, we will write exit in our test notebook. And now if we try to run this, for example, now if we try to run again this command, so now here we see notebook exited, below are the private cells. So if we come here, so the text will be visible, but the cells here will you print is not printed there. Okay, so this exit returns a value, optionally sends a string or a value back to the caller, which is basically your parent notebook, which can be used for logging or conditional logic or debugging. So workflow control, we can do it through like this. For example, you want to stop the notebook early if a condition doesn't match, right? So in those purposes we can use this exit command. Okay, so here will you print we don't see will you print here because that was skipped. All the markdown which is there will be visible, but not the values, not this Python or SQL cells. Okay, so that was your notebook. And we have another widget called data. So if we go to data.help, then we see this summarized function. So basically this summarize function summarize a Spark data frame and visualize the statistics to get quick insight. I am using this summarize, and we have this data frame and we are saying true. So basically we get this summarize value like, okay, so we have these two columns, 6 rows, 0 missing, unique values. So all the rows has 1 values, and top frequency was 6, average length was 14, 15. So this is basically giving you some statistics or some summarizing your data from your data frame. Okay, and we see here some graph as well. So if I do this, okay, then we see some graph as well, okay, showing some statistics basically. So that was your data, right? So and now if we see again what are the widgets available, so we saw about FS, we discussed about notebook, we saw widgets, and we saw data, right? And there are some other utilities like credential, jobs, meta, secrets, which is basically not available with the community edition. Okay, these are like advanced modules and are more relevant in production setups where we have enterprise features like jobs, secret, scope, or custom libraries, right? For example, this secret, so in production we never hardcode passwords, so dbutils can fetch them securely, right? And for libraries, like we need if you need a library like pandas just for one notebook, then dbutils.library let you install it without touching the cluster, right? And similarly jobs, so in productions dbutils.jobs helps manage workflows like passing data between tasks. For example, here in credential, if I see the credential here, then we see that in credential we assuming role, it works with S3. If we see jobs, managing workflows like passing data between different tasks, right? So as we progress in our video we might use them, but the most useful part was FS, notebook, widgets, what we understood. So those works fine and cover majority of what we need. Okay, so with this now we have come to an end of our video. We understood about dbfs and dbutils. If you like the video, give it a like and subscribe to the channel. In the upcoming video we will talk about unity catalog, and then we will understand delta sharing. So a lot of things coming in, and soon we will also be uploading videos related to data scientist role. So yeah, stay tuned, and I will see you guys in the next one. Thanks.